In class, we learned about the production function, and the production function basically is just a graph of the relationship between the amount of inputs that we have and the amount of outputs that we receive. So the basic premise was that initially, as we added more inputs, in this case labor, first our output rose, and then eventually it fell because adding labor, for example, on and on and on, eventually doesn't benefit us anymore. It starts to cost us. Here's an example of a production function. So as we can see, initially as we add more workers, so it's the number of workers or labor on the x-axis, and on the y-axis it's the total product, or what we would say the quantity. Initially adding more workers is helpful, and then eventually it starts to fall. One of the distinctions that we'll want to make is in between these, or in this particular range of the graph, where the rate of change is different at different points. So let's take a look at a more particular concept that gives us information that helps us understand it. That's marginal product. As we add a worker to the factory, when we add a worker to a factory or a business or a firm of any sort, what we're essentially concerned with is what their marginal product is. In other words, how much does total product increase by when we add this extra person? And it's as simple as saying quantity 2 minus quantity 1, or to be more accurate, it's the change in quantity divided by the change in labor. So long as labor, the change in labor is only 1, then it's going to be just quantity 2 minus quantity 1. The important thing worth recognizing is that different workers have different marginal product. So in our example here, when we look at our total product, it's increasing the more workers that we add up to a point, and then in this range it starts to decrease. But let's take a look at marginal product. First, marginal product is getting bigger and bigger and bigger, and that means that each worker that we hire is generating more output than the worker before them. So this is where we have increasing efficiency in this range. Then we see that marginal product starts to fall. And in this area, we have, efficiency is increasing by smaller and smaller amounts. So we call this diminishing marginal returns. Each additional worker contributes less to the total. And then finally, we reach the point of negative returns, and that's this range in here, where adding more workers causes us to actually produce less, not more. The important distinction to make, again, in between these first two phases is that as you look at the total product from 0 all the way up to 10 workers, we find the total product increasing. The difference between increasing marginal product and decreasing marginal product is here. So the first 5 workers in this case have increasing marginal product, and then we have diminishing marginal returns. Every firm will face diminishing marginal returns at some point because you can't just keep adding inputs to the production process. We can see this on the graph as well. In our stage 1, we have increasing marginal product. So as you notice, although the distance between each point horizontally is the same, the amount of growth that we see is getting larger and larger. In stage 2, the line starts to flatten out. In other words, each worker is adding less to the total product than the one before. We finally reach a maximum here, a marginal product of 0, which is also the maximum total product, and then eventually the graph starts to fall. So here marginal product is negative. So to summarize, stage 1, increasing returns or increasing marginal product getting larger. Total product is also getting larger. In stage 2, marginal product is getting smaller, although total product is still growing. In other words, we're growing, but by smaller and smaller amounts. This is the stage of diminishing marginal returns or decreasing returns. And then finally, negative marginal returns. Each additional worker causes the total product to fall. So marginal product is negative and total product is falling.